Hey everyone, welcome back to Rhythm Railroad. This video is basically a video to explain how I set up my turnouts, how I wire my turnouts to the layout, also how I set up my tortoise machines and how I wire those. And the last element is the DS64s, which are my stationary decoders that I use to control the tortoise machine, which then controls the turnout, and how I wire that so that through an address I can control everything, or through JMRI in order to have a more of a dispatcher type scenario. So I think I'm going to start off by saying that there's no perfect way of doing this stuff, and I think I'm still learning how to do it in different ways. And every time I think I have it down to a science, I see another person do it a different way. And that's where I think the confusion comes in, because especially if you're new at this and you're watching all these videos that are out on YouTube, it's kind of like trying to get diagnosed through WebMD. You're just going to find out too many things at once. And then it gets all mixed up in somebody's head, and the scenarios are different. And some people put information out there that might not be accurate. And hopefully mine is, but I know I've made mistakes in the past and I've had to go back and fix them. So anyways, my point is that depending on your scenario and which approach you like best, things are going to change with your wiring. So let me just start from the beginning, how I set up my turnouts. So I prefer using Pico turnouts on my layout. And I specifically like to use the electrofrog turnouts because that allows me to connect power to the frog, so you don't have any dead spots as the train goes through the frog. And the way you do that is through a wire that comes already pre-installed, so that it runs to all points in the frog, and all you got to do is connect the frog power to that one wire under the layout. The frog is, for me, the most important thing, because especially if you're running trains slowly, which I like to do, that's where you're going to have all the problems, right here. But there's another spot that also causes problem, which is right here, when in between the rails that land between the gap and the points, the pivoting points. This sometimes loses contact because it generally depends on if this is touching, and making a good contact to bring the power up to those rails. So in DCC world, what people do generally is they try to gap the frog so that it's separated from the rest of these rails, so that you can jump the rails with power. And I'll just explain what that means. So Pico was kind enough, or is kind enough, to actually cut the gaps for you. So they give you a choice for DCC, especially, to cut gaps, to install with gaps or without gaps. And what I mean by that is that they also come already wired across the gap in case you don't want to use that option. So again, this is what I'm talking about. There's already a bunch of options just by telling you very basic things about turnouts and how you can install them. I know there are other turnouts where this is not installed for the frog, and people wire it up themselves. They'll either drill a hole here and wire it up. I think microengineering suggests that you go through here and go right to the frog point here, because the microengineering, I think it has like a little solid plate right here where you can solder to that point, or they'll wire from the inside of the rail down and try to get to the frog that way. But going back to what I was talking about before, with jumping the track power, the frog is being taken care of, but these tracks depend on the layout power. So what I do is, depending on which wire you're using for which rail, so let's say this is your rail A and your rail B, what I do is I solder wires over here from the bottom so you don't see them, and then over here. So let's call the main track rail A here. And then this side I would call rail B. Now you're gonna say, wait a second, isn't this supposed to be rail B? And then this is supposed to be rail A from this side? Well, yes, but that's the problem with powering up a frog. That it looks that way, but you got to understand when you're going in one direction or the other, this frog needs to change polarity in order to match that. So if the train is going straight, rail A has to be this one always. But this has to be able to change between rail A and B, because if the train is in this direction, it would be a B, but if it's in this direction, then this becomes A. The frog becomes A and this becomes B. So that's where it gets tricky. Now, the job of a frog juicer or whatever you're going to use to power the frog is to be able to flip that power as you decide which route you're going to take. So that A and B that I power up come down, but only on the outside rails here. So I also soldered 2 wires here for A and B. So again, that power is running through the outside rails. But now what happens to these rails inside here? Theoretically, they're dead if you're going to cut gaps here. Because once you cut the gap here, all that power from the frog is only carrying up to the gap. Then after that, they're dead. Oh, sorry, the gap's here. So after this section here, from here to here, is dead. So how do you get power to those rails? Well, this is what I'm talking about with jumping the rails. The reason for having gaps is so that you can achieve that. So what I do when I set these up is I cut the wires under the gaps. This way they're completely isolated. So I snip that and I snip that. Once again, the frog power is juicing up all of this here. So this is all being powered. And then the outside rails, like I said, A here and B here have power. So all of this is completely powered. From the gap down to here, the only way to get power to this is if you jump it from here to there, or if you power it independently. Now, yes, you could run a wire down and another wire down. So you'd have 4 wires basically running down, and then 2 wires there, and then a frog wire. That's a lot of wires. So what I've picked up from just watching, some techniques, is that you can basically take a small piece of wire, and under the rails, go jump from here to there, and then also from here to there. Now you're going to say, what? That doesn't make any sense at all, because you're going to have shorts everywhere. Well, no, think about it. If you're in the straight main line, you want this to be A and this to be B. So as you're traveling this way, what happens is this rail right here is not being used at all. So it doesn't matter if it's A or B. So in other words, this is A, and this is also going to be A, because you're you're connecting these 2 rails together, right? And then same thing here. This is your B rail, if you're going straight, but it doesn't matter what this rail is, because you're not using that rail. So these could both be B. Now, if you switch your turnout, let me just switch it here. Sorry. So if you switch to the diverging route, what happens is now you're using the other rails that you need. So in other words, the A rail is here. This is still both of these are A, but now you're heading in this direction. But this is already A because you already connected that to this. So now this doesn't matter. So it could be whatever it wants to be. So in this case, it would be A because they're connected together. And then in this case, you're using the outside rail because you're heading in that direction, which is your B rail. So this doesn't matter if it's B because they're connected. So it might look confusing, when you first look at it, because you would think, well, how can that be that both of these are together and both of those together? You're gonna get shorts everywhere. Well, yes, you would get a short at here if there was no gaps. But since you have a gap here, you're isolating this track and this track. And then that's why you're able to jump the power from here to there and from here to there, making both of these B and both of these A. So let me run through that again. When you're going straight, this is A, this is B. So as you're traveling, they're not changing. Even this becomes A and B. Okay? So you're going straight. This is your A track right here. And this becomes your B track right here. Okay? And again, this one and this one doesn't matter because you're not on those rails. Now, once you cross the gap, what's going to happen is this is going to be your A rail. And then the frog is going to make it the B rail. This entire thing is going to turn into B. That's why you can travel this way without a problem. If you decide to go the other way, like I said, on the diverging route, now this is your A rail, which then becomes this part of the point also, and then now you're in the inside curve here. So this is your A rail. And on the other side, this is your B rail, but now we're not touching this anymore. So here's your B rail. We're completely isolated from this one. Here's your B rail right here. And so you have your A here and your B here. And then as you cross the gap, what happens is this entire frog becomes A now to provide the power for B. And now this becomes A, so you don't get a short. Okay, so before this became B completely for the A rail, but now it became A for this B rail, so that you have the combination that you need for this to work right. But again, if you don't have that gap in here, you can't do it. If these are connected, you're going to have a conflict with the power that's coming in for the frog, and it's not. That's where you get your short. So you have to make sure there's a complete gap. Some people like to cut their gap high up here, but Pico just does it for you down here, so it doesn't matter. You're still going to get power from here for the frog over here also. So that really doesn't matter. Now, the other thing that I like about Pico, and that's why I love using their turnouts, is that they've also been kind enough to actually cut out the ties exactly here where you should be crossing the wire to jump that power that I was talking about. So what I do is I'll take just a regular wire. I actually use Cat 6 wire because it's nice and thin. Something like this, you strip it, and then what you do is you just basically solder from here to there. No, this is very big. Let me just make it smaller. You basically solder these two tracks together like that. Obviously you would cut that off. And then you go back and you solder these two tracks together. So you're not going to, you can see it a little bit from the top, but it's better than having another, set of wires coming down. Plus, once you paint your rail, you can barely tell that it's there. So I set up all of my turnouts that way. So again, it's 2 wires here for A and B. It's the jump. I cut these to create the gap, and then I power the frog with my frog juicer or my tortoise machine. And that's all you have to do. Oh, and I do the same thing on the outside rails here for A and B. So A would be here and B would be here. So that's basically the general setup for a turnout. The one thing, this is just on a side note, be careful when you install the turnout. Make sure you have the hole drilled for all these things. You need holes here. You need a hole for the tortoise pin. You need a hole for your frog juicer, and then you need 2 holes here for the outside rails. And you can do it after, but if you do it after, then you're going to see the wires going out the sides. So what I do is I mark it, I drill the holes, and then this way you can put the wires down under the turnout without interrupting it and without lifting it. Because if you have wires all kinked up in there, it'll mess with the alignment. So that's that. So now that we have that covered, the only thing that's happening basically with my tortoise setup is I need this thing to go this way and then that way. So you're basically only looking at two scenarios. And what controls the side to side motion are the outside contacts. So if you take a look, I like wiring tortoise machines, again, with Cat 6 wire, because this particular Cat 6 wire comes with exactly the right amount of wires for all the contact points that are provided from tortoise. So what I do is I don't know if you can tell from that, but I just basically poke them through and I bend them, and then I just solder each one in place. And I've had these like these for probably 7 years, 6 years. And they're still together. Now what I do is I tape this so that there's not a lot of stress on these wires. So there's no stress at all right now because this is holding it together. And then, then you can just wire from there. So anyways, going back to the terminals, the only two that you really need to make that happen are the outside ones right here and right here. Now, it doesn't matter whether you wire them this way or this way. It doesn't matter. The only thing that's going to happen is that this is going to flip around when you actually power it up. So if it's this way with this kind of wiring, when you flip the wiring, it's going to go to the other side. It's as simple as that. The only other wire that I would consider would be the green one in the middle here, the solid green one. That's my frog power. I forget what number contact that is, but it looks like I wired this up so long ago. 1, 2, 3, 4. It's like 4 from the left for the power. So 1, 2, 3. It's this one right here. That's where my thumb is. That's giving you the power for the frog that we just talked about. Now, disclaimer here, I haven't really done it that way because I had a bunch of frog juicers. And if you don't know what a frog juicer is, just look that up. I'm not going to get too far into what a frog juicer is, but it's a digital version of this. So this is mechanical. When the thing moves over, it flips a switch inside, giving you reversing the polarity of that wire, which then reverses the frog. But you have to have track power going into this so it knows where to put the power. So, I just avoid it altogether and I just put a frog juicer, but I think I will be using these with the actual frog power because in this scale, it's so much bigger that my frog juicers come in 6 frogs at a time, the ones that I have. And now they're so far away from each other that it really doesn't make sense for me to run wires everywhere from one central location. So the wires right here, this is obviously going to be under the turnout. So I might as well just use the wire from here to there and then I'm done. But I'm not going to talk about that right now. If you are gonna power up the tortoise with the track power in it, it's the diagrams. You can just Google tortoise, wiring, tortoise machine wiring, and they'll tell you exactly where to put what. Okay, and then that's going to line up obviously with the track the way you have it set up on your layout. So what I do, going back to the outside contacts, is I basically take those 2 wires, so the orange, and I know that they're orange because I did them all the same way, the solid orange and the striped orange, those are the ones that are going to go out to the DS64. Now, if you weren't using anything digital like I'm doing, you could just wire these out to a double pull, double throw switch with it like a toggle switch. And basically all that switch does is that when you go one way, it throws the current this way. And then when you go down, it flips the current, which then gives you what I explained before. It basically just gives you either that way or this way on the tortoise machine, which then obviously switches your point. So that's as simple as that. Now, when you go to the DS64, what happens is you only need 2 wires. So these 2 wires go over to that decoder, and then there's an input. I'm going to try to walk over there so I can show you. Okay, so my DS64s are the white boxes that are on the bottom here. And each one of those white boxes control 4 independent turnouts or tortoise machines. They do other stuff also, but for my situation here, I'm only using them for the tortoise machines to go one way or the other. The wires that I'm telling you about, the orange wires, actually come in through the bottom here. Now, it doesn't matter which way you hook them up, whether you go, you know, solid on the left and striped on the right, or the other way around. That doesn't matter, because there's so many ways to reverse that. If you don't like the way it's set up, you could either just unplug it and flip them here, or you could do it over at the tortoise machine. You flip it there, or you could do it digitally through a computer, or I think you can even do it through a throttle, where you reverse the setting, and then the actual decoder is going to send the message backwards so that it actually looks correct on the layout. So as long as you have power going to the DS64, because it does need 12 volts to be able to power that, and then that powers the tortoise. As long as you have power going into the tortoise, you can hook up the 4 independent tortoise machines from there. The other possibility is that you can, if you have a crossover where you're using 2 tortoise machines at the same time, meaning they're always going to move in the same direction. So, you know, it's actually the opposite direction, but it's consistently in the opposite direction. You could wire the tortoises up together at the layout and then bring just 2 wires up to here and do it that way. And that'll control. So if you have, you know, if you have 4 crossovers, you're actually able to do 8 turnouts from one of these DS64s, but you can't move them independently. That's the difference. So yeah, so that's basically what happens with the DS64. Then the top wires that you see coming out of the top of the boxes here, those are basically data wires. That's just data coming out of there through something called LogoNet. If you're not familiar with the Digitrax products, LogoNet is basically what controls all the data back and forth between the main system and every other component. So everything here is talking to that and to my throttle through what we call LogoNet cable. And LogoNet cable is basically like a phone jack, but it's got 6 pins instead of 4, which is what phones wouldn't typically use. So now after you have that wired up, then all you got to do is program the DS64 to talk to the to JMRI or to your throttle in a specific address. So you would have to give each turnout an address that you like. It doesn't have to be anything from like a book or a manual. You can just decide where you want to do it. So what I did is I almost made it into like subcategories. So like my 500 series would be my 5th box in over there. So this is my 5th DS64. This would be turnout 1, so I called it 511. This is my turnout 2, so it's 522. And this is 533, and 544 would be the next one, which I don't have here. But that just keeps my planning very clear in my mind, because then I know which box. If something happens here, I know that it's in the 5th DS64, rather than doing some random address and then I can't locate that. Same thing over there. So that would be my 4th box. That's my 4th DS64. First turnout, second turnout, third turnout, and so on. Now that's just a system I developed. You can do whatever you want. The only thing you have to be careful with is that you don't set an address that's conflicting with an address from some other component, like an auto reverser or a block detection or something like that has that address. Now, you know, you have to read a manual and you have to kind of check to see what your components are already set up for. And if you have a conflict, it's easy to change. It's just you got to know if there's a conflict. Otherwise, you know, the computer won't know what to do. When you hit 533, for example, it'll try to, like, you know, detect and then also switch this. It'll have conflicts. So that's that. Now, that'll get you to be able to run things, you know, without any problems. So, for example, let me see if my throttle is actually powered up. Yeah, okay. So if I go to my throttle, and I like to use Y throttle on my phone. It's just my preference because anybody can come here with their phone and, you know, download this for free and then just that's automatically a throttle. I don't have to be hooking things up, and there's no wires, and there's no special things that I have to order. It's so easy. So anyways, if you take a look at the throttle here, so if I go to my main panel, which would be this, what happens is when you scroll here, it says LT, which stands for LocoNet Turnout. I explained LocoNet already. And that allows you to enter the address of any turnout in your system. So for example, if I want to switch, let's say 533, all I got to do here is type in 533 and then either close it or throw it. And now it's working. So again, so right now it's in the diverging route. So if I close it, it controls it. I'll do it again. Throw and closed. And then if I want to do this one, it would be 522, 522, and I can again close it or throw it. Okay? And if you take a look, this one's actually backwards, so I have to fix that. But the reason why I don't even bother right now is because JMRI kind of does that for you automatically. But I should fix it, because if somebody wants to do it manually like this, they're going to be, doing the wrong thing. Okay, so that's basically all you need to know about getting to this point. Now, the only other thing is, and this is where I think people really get turned around, including me. You have to be able to situate the turnout in a way that, according to your track power, you know how to cut the gaps correctly. And now, if you don't know what I'm talking about with gap cutting, you have to, once you get past the frog, you have to isolate it not only here, but also after the frog. Otherwise, the frog power is just going to continue to run through the inside rails, right? Because remember, this was all being powered by the same source. So now all of this would be the same. So all of a sudden, if the frog power is track A, now you got track A here, that's a conflict, because it's not going to line up with the outside tracks. So here's where people get turned around. Here's a situation where I have a main line that's going to a siding, right, through the turnout. I have the turnout wired the same way. I jumped the tracks with the wires, everything is under the layout. And I have a frog juicer right here that is powering up my frog. So this takes care of 6, but I only have 1 working for that right now, until I figure out where I'm going to use that frog juicer, later. So if I take my throttle and I call up 122, because that's the address, 122, and I close it or throw it, you can see it's working. So that address is talking to this tortoise machine down here, and it's telling it to go one way or the other through the DS64. Okay, so we got that down. Now, once we cross the gap, let's say we're going into the main line, which would be this side here. Remember, this is A and this is B. So as we go through, this becomes A, it is A, and the frog becomes B. So at some point, I'm going to have to cut this gap for the frog to be disconnected from, from the other side. Otherwise, when we go that way and this becomes A again, it's going to conflict here. So right now it's B. So let's see. We continue. You have your A closer to me and B's on the other side. But what I did is I kept it going all the way to here. Let's see, I marked it here. So why would I put a gap so far away from the frog over there? So in other words, the frog is actually from here all the way through the frog and down to the next gap. That entire thing is being powered by this thing. Okay? Now the reason I did that is because my signal is not going to go here, because I would have would foul up the track here with the other train. It would crash. So what I did is I wanted to put my signal here. That's why actually it's going to be just behind it. So that's why I cut my gaps there, so that when the train comes through, it'll knock down the signal as soon as it hits that. Now, if you notice, I double gapped it here. Now, why did I double gap here if this is A and that's B? Well, because I want this to be a separate block from this one. But I still need to cut the gap for the frog here. So that's why you would need a double gap here. If this was the other way and this was A track and this was B track, then you would only really need to cut on the other side. Well, that's not true because you still have a frog. I'm going to show you an example. I just thought of it for the other scenario. But here you would definitely need a double gap because you would have a, that's where I want my signal to sit right here. So again, once you cross it, you would go the other way. Now, if you go the other way, if we're going to go into the diverging route, you switch over, then here's a tricky little thing because I'm going from a turnout to a turnout because there's going to be an industry over there. So what I did here is I still have my gap for the frog here because you have to, right? You have to disconnect the frog from the rest of the rail. So here, my frog is running from this gap into here. So notice, you don't have to have your gaps right next to each other. For in this scenario, it's here, but then the other side of the frog is all the way over here where I showed you before. There's nowhere near each other, but it still works because it's independent, so to speak, when you're in this route. So now, if you notice, I cut the gap here, but not here. Why? Because this is the B rail, this is the common rail, and there's no reason to interrupt it. The computer only needs to see the A rail when you jump from block to block. That's why there's one gap here. Okay, now the problem here is that because you're going into another turnout, this A rail has to get reconnected. So the wire, you can see the wires under the fish plates here, under the rail joiners. There has to be power going back to this rail again. So that's where the power is resuming up to the gap here. So up until this point, this was powered by the frog. And then once we jumped, now it's powered by A again. Now, my block actually doesn't change until here, until we get to this rail. So I want the train to think that it's still, I want the JMRI to think that it's still on that track, even as it's going through the turnouts here, because this is all industrial, okay? And if I have a signal, if I have a train waiting here, and this switches blocks, it's going to confuse what's happening on this side. So I actually wired all of these to the same block, even though you have your frog gaps. So all my A rails on the divergent track and on the A rail of this turnout are going to the same block, which would be A3 in this case. So as you can see, all these red wires are different blocks that are going through, so I can get all the blocks set up. They're all running all the way through. And so the A rail is only hooked up to that particular block that I want to be detected. So again, this is still the same block. Let's call it block 1. So block 1 is this thing, it's the main line. It's also this, and it's also this, and it's also this turnout here. But now this is where my signal is going to sit. So my signal is going to be, there's going to be a cantilever thing here. So it's going to be here, which is, pretty much where the other one's going to be. So this is where I had to do the double gap. Why? Because I need to tell the A rail wire that there's a new A rail wire hooked up here. So A3 was the other block. This one is A2, see? So that's connected to this part, this side. A3 is here, A2 is here. So that tells the computer that these are two separate blocks. But you still need to cut a gap here because there's a frog involved. And that frog's going to be flip-flopping every time. That's why you need that gap there. Again, if you don't cut this gap, now you're considering this entire rail all the way through the layout, basically, the frog. And as soon as you switch it over there, it's going to short. So that's why you need that gap there. Now, once you get into this side, now you're just talking about, a single main, just like here. So there would just be A rail, B rail. And that's not going to change. That goes all the way around. That's not going to change at all until you have the next conflict, which would be at the next turnout right here. So at this turnout, let me just move this up a little bit. At this turnout, and this video is becoming a lot longer than expected, but anyways, at this turnout, it's the same situation, but it's facing this way. So let's see what I did here. I don't even remember. So here's your A rail. I want the signal to sit right here. So I had to cut the gap because I have a frog coming up. So that would conflict with A if it switched. And then I also need a gap here because I need to tell the computer that, oh, see, that's a mistake right there. I really didn't need to gap this. Now, if you gap it, it doesn't matter, but I should have just left one gap there. This is the scenario I was trying to show you. Because this is the common rail. This doesn't matter. And there's no frog that's going to interrupt it. So this is still your B track. So I should have really never cut this. But like I said, I make mistakes also. So what I had to do here is I had to connect another wire on this side to the same common wire. So that this becomes basically one uninterrupted signal. Now I'm kind of kicking myself for making that gap, but it doesn't matter. It'll still work as long as you have the same power on this side. So basically, think of it as a bridge. I basically just took a wire from here and a wire from here and went to the same common wire bus on the bottom, which is your B bus. Okay, the A one is the one that had to be gapped because there's two situations. One is the block detection, and the other one is because now the frog is connected to the A rail, and that's where you have the conflict. And then obviously it would continue. B would be that side and A would be this side, and then to the next situation. So yeah, so that's what it is. See, I'm learning as I teach this, as I talk about this. So basically, once you flip the turnout, that's where you have the situation that I was talking about originally. Cool. I usually learn things better when I explain them rather than when I'm just doing them. So that's how my life goes. All right, so that's basically it. I hope that helped. I know that it took me a while, like I said, for me to absorb all that stuff. And, I also said this, there's other ways of doing it. So if you're not running block detection at all, most of this stuff kind of goes out the window. If you're not using frog juicers, some of it goes out the window, or maybe you're using a different device. I don't know. So that's what I'm saying. But in my scenario, this is what I'm doing. And it's been working out great. And I had an N scale layout before this, a pretty complicated layout. And I did the same exact thing, just in tiny form. But it all worked exactly the same way. I did make a lot of mistakes with double gaps there because I made everything double gaps. And that's where I learned that I didn't need to double gap everything. So when I came over to this one, I thought I had it all under control, and then I just showed you the mistake I made there. So there you go. Okay, so I think we're going to end the video here. Hopefully this helped, and let me know if you have any questions down below. Thanks.